RLC series circuit. Let's draw RLC series circuit. This is resistor R. This is inductor with inductance L. This is capacitor with capacitance C. The unit of resistance is ohm. The unit of inductance is Henry. And the unit of capacitance is farad. Now this is called as series. Now let's give it AC supply. So this is AC supply with voltage small v is equal to Vm sin omega t. This is the standard expression for AC voltage, AC sinusoidal voltage. Let's say the voltage across this resistor is VR, the voltage across this inductor is VL, and the voltage across this capacitor is VC. Now let's say this is current I. Now for this resistor, inductor and capacitor, the current will be same. So here also the current will be same, but the voltage will be different. So for resistor, the voltage will be in phase. So it will be like this. Voltage will be in phase and this voltage is VR. And here the voltage will lead the current I. So this is VL. So it will lead the current I by 90 degree. And for capacitor, the voltage will lag the current by 90 degree. So this is VC. Now here opposition to current due to resistance is given by resistance R. And here the opposition to current due to inductor is given by XL, where XL is the inductive reactance and it is equal to omega L, where omega is the angular frequency and L is the inductance in Henry and its unit is ohm. The unit of resistance is also ohm. Now the opposition to current due to capacitance is given by XC. It is called as capacitive reactance and it is equal to 1 upon omega C and its unit is ohm, where omega is the angular frequency and C is the capacitance. Now the voltage across resistor is VR, the voltage across inductor is VL and the voltage across capacitor is VC. So the sum of this should be equal to this. So here the maximum of this, that is Vm, is equal to maximum of this is VR plus maximum of this is VL and the maximum of this is VC. Now here we can see all of them have different phase, that is here voltage and current are in phase. So it is in phase. Here the voltage is leading. So here we can write voltage is leading. Here the voltage is lagging. voltage is lagging. So we cannot add them algebraically. So this will be with phase. Now to add them with phase, we will use phasor diagram. So let's take I as a reference because I is common in all of them. So this is our reference I. Then for resistor, the voltage will be in phase. So here this will be our VR. Then for inductor, the voltage is leading. So let's say this is VL. Then for capacitor, the voltage is lagging. So this will be VC. Now here we can see the VL and VC are in opposite direction. And here the VL is greater than VC. So for this condition, we will subtract this much length from this VL. So let's say this length is this much. This is the length of VC. So this remaining length will be VL minus VC. So this is VL minus VC. Now if we want to draw resultant of this, so there will be a parallel line from here and parallel line from here, and this will be our resultant. Now here we can see the resultant is Vm. So this is Vm. Now again, first we will give it a name. It is a phasor diagram. And this angle between voltage and current, that is resultant and current, is angle phi, and it is called as resultant. For this phasor diagram, we are considering XL is greater than XC. So here we can write XL is greater than XC. So we are considering XL greater than XC for this phasor diagram. That's why VL is greater than VC. Then we can redraw this triangle. So it will be, if we redraw this triangle, so it will be like this. Now here we can see this length is equal to this length. So here we can write it is VL minus VC. VL minus VC. So this arrow, and this is VL minus VC. This is VR, and this is angle phi, and this is Vm. This is VR. Here we can write it VR. Now here all the quantities are in voltage form. So we can give it a name as it is a voltage triangle. So it is voltage triangle. Now if we divide all the quantities by current I. So if we divide Vm by I, so here we can see, if we divide V, or here we can write, first we will divide VR by I, so it will be, or we can write VR is equal to I into R according to Ohm's law. Here we can write VL is equal to I into XL, and for VC we can write I into XC. This is according to Ohm's law. Voltage is equal to current into resistance. Voltage is equal to current into inductive reactance, and voltage is equal to current into capacitive reactance. Now here From this equation we can say that VR by I is equal to R. So here we can write, if we divide all quantities by I, then we get Vm by I. Then first we will write VR by I, then we will see what is Vm by I. So VR by I, it is called as resistance. Then VL by I, it is called as inductive reactance XL. And then VC by I, it is called as capacitive reactance XC. And here when we divide Vm by I, it will be Vm by I, it is called as impedance. So we can write Z is equal to V by I, it is called as impedance. So impedance means total opposition to current of this all three. Whatever opposition to current is given by all of these three, it is called as impedance. And its unit is also ohm. Now if we substitute here, let's copy this circuit from here. And now we will replace this Vm by Z. So this will be Z. And here this VL will be replaced by XL. This VC is replaced by XC. And this VR will be replaced by resistance R. Now here all of these are in impedance, resistance and inductive reactance and capacitive reactance. That means opposition to the current form. So it is called as impedance triangle. Impedance triangle. Now from this impedance triangle, according to trigonometric formula, this is the opposite side. So it is called as opposite side. This is the adjacent side. So it is A. And this is the hypotenuse. So this is H. So there is a formula for this, that is sin phi and cos phi and tan phi. So the formula is, we can use this shortcut OA, or we can take capital A, OAO, then divided by HHA. So here also we can replace this A by capital A. So OAO divided by HHA. That means opposite side divided by hypotenuse. This is for sine. So it will be opposite side. Opposite side here is XL minus XC. XL minus XC divided by hypotenuse. Hypotenuse is Z. Now for cos phi, it will be adjacent upon hypotenuse. So adjacent is R divided by hypotenuse. Hypotenuse is Z. Then for tan phi, it is opposite. Opposite is XL minus XC divided by adjacent. So adjacent is resistance R. So these are the three formulas we get from this impedance triangle. Here we should be dividing this by maximum current Im. So it will be like this. And here also this should be IM, and here also this should be IM. Now this is correct. Now from this impedance triangle we can calculate the value of Z. So Z is equal to, according to Pythagoras theorem, also we can calculate. So it will be finally like this, under root of R square adjacent side square plus in bracket XL minus XC, XL minus XC square. So this is according to Pythagoras theorem. For right angle triangle, this is a right angle triangle. Here this will be 90 degree. And the unit of this impedance will be ohm. So this is also the formula for impedance. And also Z is equal to Vm by Im. This is also the formula for calculating impedance. Now also the current is given by, first the voltage is given by V is equal to Vm sin omega t. This is the voltage. The current is given by I is equal to Im sin omega t plus minus phi. Now why this plus minus? Because there will be a phase difference of leading and there will be a lagging phase difference, or maybe there is no phase difference. It will be depend on the load, that is whether the combination of these three is resistive or whether the combination of these three is inductive or whether the combination of these three is capacitive. If the combination of this is resistive, then the phase angle will be 0. So I will be Im sin omega t only and this term will be 0. And if the combination of this is inductive, then here this will be lagging. That means here this sign will be minus. This will be minus phi. And if this combination is capacitive, then this should be positive. So this is current I, where Im is the maximum current and omega is the angular frequency in radian per second, where here we can write omega is equal to 2 pi f radian per second. So this is omega and t is the time in second. Here we can write time in second. This phi is the phase angle. Phi is phase angle for leading, or here we can write for resistive circuit. It will be, for resistive circuit, phi will be 0. Here we can write phi is equal to 0. For capacitive circuit or for inductive circuit, first for inductive circuit, the phi will be, this phi will be negative. Phi will be negative. Then for capacitive circuit, phi will be, here we can write phi will be positive. Now This is the impedance, voltage, current and angular frequency. Also remember, the unit of impedance is ohm. And we have calculated this for XL is greater than XC. So this is all about RLC series circuit. If you want all the notes of this video, then visit the link in the description below. There you will find thousands of questions and answers and videos related to electrical and electronics engineering. Thanks for watching.